Hello everyone. In today's class, we will see how to find the operator of orbital angular momentum. So let's begin our class for today. So firstly, we will see the expression for orbital angular momentum. So we represent the orbital angular momentum with capital L and we simply represent it by R cross P. This order is important. Have an electron moving in this orbit and its momentum, since its velocity is in this is anti-clockwise, so our momentum will be in this direction and radius is this, so we have to do the r cross p. So our direction for orbital angular momentum goes upwards. So this is the direction of L. So we simply have to do the cross product. So if we have R is equal to xi cap, y j cap, and z k cap, and our momentum is represented by px. All these we will write all the three components for this vector. So we simply have to do the cross product. So x, y, z, px, py, and pz. So we are generalizing the so our expression becomes something like ypz minus zpy and then minus a j xpz minus dpx plus k cap and then xpy minus ypx. So we get the different components. So we can rewrite the components. Lx component is this, ly is this, and lg is this. So we can rewrite this on the next slide. So we can write it here. So our Lx is equal to ypz minus zpy and ly is equal to xpz minus zpx and then lz is equal to xpy minus ypx. So we simply have to convert all these components into operators. So Lx operator, we represent this with cap. So y operator into pz operator minus z operator, py operator. So we will get all these operators. And we have done in earlier classes what is the operator, momentum operator in quantum. So we have to replace it with that operator. So we know the momentum operator is equal to minus iota h cross del by del x, y, z, whichever component is this. If we have x component, then we have del by del x. If we have py, then it is minus h cross del by dy. And similarly for pc, minus h cross del by del z. So we have to use these three and substitute here. So we get Lx operator is equal to y operator into, we will take the minus iota h cross out and y del by del z minus x minus z del by del y. Similarly, we can write for Ly, which is equal to minus iota h cross x operator del by del z with minus sign plus z del by del x. Similarly for Lz, minus iota h cross, then x operator, then del by del y minus y operator del by del x. So these are the operators for each component of orbital angular momentum. So this is it for today. If you have any doubts related to this topic, you can ask me in the comment box. And thank you for watching this video. And please do like, share, subscribe to my channel.